Welcome to the wasmCloud machine learning subgroup for February the 17th, 2022. Christoph, do you want to lead us off, give us an update on where you are?
Let me share, then I will do so. I prepared an agenda proposal. I mean, it's bigger than the content almost. But so my proposal is that to go over the status quo from like 5,000 feet perspective and then reiterate and zoom in, because at least that's how I like it, to get the big picture first and then the details afterwards until time's up, maybe. So what's then the status quo is, yeah, we have some sort of implementation of all the technical stakeholders now. Let's briefly come to back to the question, what are the technical stakeholders? That sketch a bit older, but it's based on on our summary from the first meeting. So we have a bindle server now. We have that capability provider IE, so inference engine. We have an Inference Actor, that's that I, and we have an Inference API, and then an HTTP server. So more or less, and usually rather basic, we have an implementation of all of that. Then concerning the capability provider, that's ready for being tested, and yeah, that was an issue during the last few days, because I had a bug which I didn't get resolved. So Steve helped me a lot. Yeah, so basically after Steve having resolved that, I have to upgrade dependencies. I tried that, it's not yet working, so maybe a little mistake somewhere, but I'm very optimistic that we have it, so we can start testing systematically now. Concerning the contract, yeah, I changed it from 2 weeks ago. I think it's not the final version because Steve built in unions. I also have a little bug somewhere, so I have to upgrade dependencies there too. And then, yeah, there are some minor things like tensor type and index. I think we want to change. Okay, then this is the status quo. And my proposal is, what I really would like to discuss is, I stumbled upon the Inference Actor myself. That has a contract which is very similar to the contract of the capability provider itself. And then maybe we can rediscuss the contract of the capability provider. So if there are some open points left. And well, the other points I think are rather optional. I've one question: if we really want to have that whole application, if it's possible to have a manifest, because all the examples I've seen, they are in pre-OTP. I have not seen any examples with manifests in the OTP generation. Yeah, that's basically it. Maybe you have some comments about that.
Steve, you've been super engaged in the work stream. Do you want to maybe take us through these points one at a time as far as the discussion points here?
I don't have much to add, unless I don't know what are you asking exactly. I'm happy to have Christoph keep going,
Okay.
unless other people have questions.
Yeah. Great.
So if there are any other questions, comments, or points you're particularly interested in, we can go over there. Otherwise, maybe I would start asking my questions, and I would start with the Inference Actor. So let's maybe come back to that picture. So that sketch, yeah, what did we say? So maybe we start from the left. So there are requests coming in via HTTP, and they are routed somehow to the Inference API. And then we said, okay, that will be routed to the Inference Actor, and then routed to the capability provider, which comprises the inference engine. when I implemented this, I also did the Inference Actor, and I did a contract for that, and that currently is a copy kind of the capability provider's contract. And that seems awkward. So I understand that I need a contract for that Inference Actor. And I mean, there's no particular state, so no knowledge that Inference API or that Inference Actor has to know. They just route requests. All the state is in the capability provider, which itself gets a state from the bindle server. So that's cool. But somehow, what's the role of that Inference Actor? I mean, what value is it supposed to act? Maybe I've got a flow in my head, but I do not see the added value, except that I know it should really validate the input it's getting. But to be honest, validating input we could also do in the Inference API, right? I mean, in that what it gets from the HTTP server. So what's the role of that I in that picture?
I have the same question. Why aren't IAPI and I just one circle?
Oh,
Steve?
I was hoping Andrew had an answer to this.
No.
So the inference engine is I think the only thing. I mean, the provider on the other end of that inference API is the only thing we need. I had imagined if there was going to be an actor that it would be a different engine, sort of like running on a mobile device or something that kind of like the use cases for TensorFlow Lite, where you're running maybe a smaller model that doesn't need GPU access, that might not even have a Intel CPU that's running on an edge, an embedded device or something. So I could see different implementations of that API, that inference API, some in actors, some in capability providers, but that our first plan going forward was to just start with the capability provider.
Okay, yeah, could be.
Is there a way to go directly from, looking at the numbers here, number one, the request comes in through the HTTP provider. What is it possible for the number 2 line to go directly to the engine?
Absolutely.
Or does that just not happen in wasmCloud?
Yeah, that would be possible. And honestly, it feels like that would be the way to go currently. I mean, I sketched that based on Kevin's summary after the first meeting. So maybe I thought I didn't get any idea. So I just sketched it and, implemented that. But now it feels doubled. As you said, Andrew, I would also go from, well, the 3 is not from I API to I, but the 3 would be from I API to the inference engine.
Okay.
So in wasmCloud, a capability provider can't talk directly to a capability provider. So you would need an actor to take the HTTP request and send it to the capability provider that's running the inference engine.
Okay.
Okay, but the inference API is an actor, right? I mean, the round circle between 2 and 3, so everything's fine, right?
So we need at least one round circle, but we may not need 2.
Absolutely.
Yeah. Okay, I see. Okay, so this is a detail about wasmCloud that, like, hey, you just have to have an actor in the chain. And
well, there's some reasons for that. When we think about the model, all of the round circles here are stateless and reactive. So let's think about a situation where we wanted to scale this to thousands of requests per second. Now, obviously, in this particular case, we may be slightly blocked by having the inference engine, right? And how many inferences can it take? But you would scale then at the actor level both vertically within a wasmCloud host or horizontally across multiple hosts.
Mm-hmm.
So that would give you then the ability here to have, inference actors and receivers running, in one place, and then they could be talking back to an inference engine that's back in the cloud. So because, if we think of this as layers here, there's a layer between the actors and the inference engines, and it's separated by NATs, right?
Yeah. Yeah.
So across that NATs, or let me actually share my screen real fast. I'll pull up just a graphic here. I probably need a better one than what I have here. But just to let me just paint this visually here. As soon as I can find the share screen button. Oh my gosh. Have I been on that many calls like I've just completely lost the button? Oh, it's right here. It's the one in green at the bottom of the screen. All right, so let's pretend that these edge devices were, in schools or automobiles or something like that. We could have the HTTP providers here with an actor, and they could then dispatch to a larger inference engine that's running as a provider up here in the cloud, right? So that's the kind of model that we have there. And then that scalability would be if, down here at this particular location, let's say, we need to accept, I don't know, however many requests per second, we could scale the actor here. It probably makes sense in this case for us to think about having a queue between the HTTP and the inference engine, but that's probably a detail for later that you could build on the fly for an implementation. For the MVP, I think, thinking of, even if it's all here in one server, an HTTP server talking to an actor that then dispatches to the inference engine is probably the right way to go. Steve, did I do an okay job explaining that, you think, or is there another way that you might do it?
Yeah, I think, another way to think about it is that it might not always be the HTTP server that we use to invoke this. So you might have your business application running in actors. Maybe you've been scanning some images and you need to go send it off for additional processing, or you've got a chunk of text that you need turned into audio through a text-to-speech engine. So there could be actors that have that, or you might have a protocol that works over NAT. So in any of those cases, you'll end up having an actor send it over the Inference API to the provider.
That's actually that's additionally as compelling a reason as to why we might do that as well. Hey, Maxim, welcome to the call, by the way.
Thank you.
Christoph, I think if you want to go back to sharing your screen again, that was great. But yeah, so from a detail perspective, Andrew and Christoph, is that clear why we want that actor there? But I think we are all agreed that we only need the one actor here. So the one circle in our implementation.
Okay, correct. So cool. Then we can strike out the other one. Perfect. Okay, let's see what else we have then. Yeah, maybe coming back to the question. So if we have all, say, I always refer to as technical stakeholders, so all the participants on board, can we say start the application based on a manifest currently? What is that? What is the state? Because as I said, you only have examples from that pre-OTP generation.
So this is a case are you talking about the basically starting up a system from scratch and putting all the actors and providers in place ready to run workloads?
Exactly, because from the workflow, what is now the most important thing? That is unit tests, right? I mean, I really have to test the capability provider. That's first, and that's we were debugging that, so should be possible. And afterwards, we for a demo case should have well, the whole application. And then I figured out that the link definitions, for example, we have to provide them. We have to start all the actors, capability provider, and that's easiest done by that manifest, correct?
Yeah, so we don't have a manifest in the current system. There is something on the roadmap, but that's not going to be available for at least a few weeks. So I would say in the meantime, you're probably looking at writing a shell script, maybe something like the run.sh that's in the example pet clinic. And I can help you with that.
Okay, cool. Yeah, good idea. Super, then that one is checked. Yeah, I mean, then the next point would be a bit not philosophical, but it's further ahead. But I stumbled over one point referring to the time maybe after the HTTP interface. Let's come back to the sketch here, because on the one hand we have that sketch, that illustration. So what does it mean? That requests would currently be sent or will be sent via HTTP with the data that Inference Engine should do a compute upon, right? And then it gets an answer. HTTP is not known for low latency or high throughput or so. And on the other hand, people are talking about their Coral dev boards and other things. So maybe, at least in the long run, we would like to have a different interface. What I dream about, Liam and Bailey, if you're referring to no-cat based on a camera image and so on, would be nice to have, at least conceptually, another capability provider in that system, which provides maybe images or whatever, maybe acoustic signals, or in my case, from my day job, maybe logs, and then provide that directly or indirectly to that inference engine in a very fast manner. And that only results are forwarded either in a database, KB store, whatever. But maybe I do not want to make one request for each and every compute. Is that meaningful? At least, I mean, what would I want the Coral dev board with the TPU for if I send HTTP requests for every compute? That doesn't seem to feel right.
So are you talking about a batch interface where you could process several images?
Oh, yeah, no, yeah, not necessarily. Say I would have beneath that IE, so Inference Engine, another capability provider. I mean, could deliver one image after the other, but potentially very quickly, like 30 frames per second. Don't know what a TPU can compute.
Sure.
Like a streaming queue type of thing.
Yeah.
Right?
Yeah.
Yeah, you could definitely do something like that. You could have an input queue and a queue of results.
Mm-hmm.
Sorry, go ahead.
No, I was just gonna say it feels like WebSockets type of a interface, or quick interface, where it's boundless. You're not.
Mm-hmm. Understand? Yeah, could be one.
I think what would be powerful is if we can get the MVP up here with HTTP, we can reuse those components like building blocks to prototype a faster mechanism. So perhaps what it might look like is there is a capability provider for a camera, and then that can feed to an actor that just streams it directly into the inference engine or something along those lines. Mm-hmm. I think those are some good. It's a good discussion exercise around how we might do that. And Steve, maybe we can brainstorm some stuff as a to-do with Kevin and see what Kevin's ideas are on the topic.
Yeah, I'm pretty sure Kevin would suggest using Nats for that queue, and so you could put all that on a Nat subscription and have an actor listen to those and shove them into the inference engine.
Yeah, that's what I suspect as well.
That sounds cool. Maybe he can sketch anything in that machine learning channel. I don't know if it answers already then, at least conceptually, the question how you would start that. You know, it's kind of a service, right? That inference engine provides a service, and I could kind of register or start it, or I could just leave it. So, and when I started, I mean, me as a requester, the request could go over HTTP, but then the data flows differently. And so that, I mean, stopping of that service, do you have that answer in mind, or was it part of your sketch, or is that mechanism something else? Do you know what I mean?
It could be, to Steve's point, if it's a Nat's topic, it could be, you know, that we have an actor that listens for certain types of topics or topics that are named in a certain way, and then does the connection. I think that. I don't think that I think that we've got a lot of different options here we could try, and we'd really need to kind of dial it in with some, you know, some service level objectives for what we want to hit as far as what we're trying to achieve here. But to me, I feel like we're on the path to get there with, you know, knocking out an MVP first. The capability provider isn't going to unbind itself, so it's going to be in the sense of wasmCloud. Once you start it, it's there waiting for link defs to be attached to it. And then those actors, you know, we already have the ability, the actors, the round circles have the ability to talk to NATs. So if Steve's point, instead of HTTP, we're connected to NATs, we could have multiple strategies here for, I think, using one inference engine on the Google Coral TPU, if that's what we're going to go with, or the Jetson, and then have multiple ways to input to it or something like that. Steve, your thoughts?
Yeah, I think that's all almost implementation details. I'd love to see us get the model up and running with some protocol. I was going to ask about the model. Are you using ResNet, or what is the image recognition model you're using?
Oh, I do not use any yet, but I would go with the examples. I think 2 weeks ago we had a look on the examples what the Rado guy uses, and I think it was MobileNet. I have to look up in the test folder.
Yeah, okay. There's a couple versions of MobileNet out there.
Mm-hmm. I've seen V2 should be working. So version 2.
Okay.
Mm-hmm. Is that important, or do you have something specific in mind?
No, I think that's great. There's a handful of decent models. I wanted to I think it would be great if we could find one that's has a TensorFlow implementation as well as an Onyx, and both MobileNet and MobileNet does satisfy that criteria.
Okay, I understand. Yeah, good idea. Mm-hmm.
Hey, Christoph, I have a couple comments. I was just, while we've been talking, I've been looking at the wasmCloud artifacts repository, and by the way, good work on getting all that stuff. Looks like there's a lot of work that's been done there. Okay, I think for me, the general design of the providers and the actors and stuff is it's pretty much there, right? I think what's missing from that repository is how to run this thing. Like, I think you were asking that sort of earlier, right? Like, how do I, you know, get wasmCloud up, get the Bindle server up, get all this running, and send my first HTTP request or whatever that is. I think that's important, because the second part is I think we need to spend some time running requests through the system and seeing what happens and what errors we get, because I suspect it won't be, you know, send any bytes and you'll get a good response. I've had issues with this in the past, where you have to sort of like format the tensors in just the right type, right? You have to decode the JPEG image into something that that your backend understands. And I think there'll be a little bit of work there. And I think it would be an advantage to quickly shift into trying to find those issues quickly.
Yes, you're absolutely right. Yeah, I was hoping to. So until yesterday evening, Steve and me, we were having a look at the test of the capability provider itself, and that doesn't accept HTTP requests, but that expects that the contract method is being called. So you're absolutely right that this should be the milestone. I hope to achieve it within the next sprint. So all the time between our two bi-weekly meetings, for me it's like a sprint. So maybe with a bit of luck, within the next sprint, that should be done.
Sure.
That the third party would be able to use that. You're right. And then
no pressure though. I'm not. No pressure. You're the one doing the work. So hey, whenever. I'm just saying that getting to the point where we can debug the inference part is going to be an advantage, because I suspect there's going to be some like foot guns there that we haven't yet seen.
Yeah, absolutely.
Did you say foot guns?
Yeah, like you think the code's going to work, but then it shoots you in the foot.
All right.
Yeah, that is. Yeah, I listened to that. Yeah, accepted.
Is there I know you and Steve have been working on this a bit, Christoph. Is there a demo that we could walk through? Is there, do we have it up in, working even like piecemeal yet, or are we still trying to focus on that?
There's no demo yet, but I mean, goes along with what Andrew said, right? I mean, that would be the next thing to do. So, oh, sorry. Yeah, but no, not demo yet. So would be within the next milestone. Yeah.
Hey, I have a comment for the wasmCloud guys. I think watching Christoph do this is pretty valuable for you guys to see how easy or hard it is to create the interfaces, to create the providers, to set everything up, to explain how to set everything up to other users and all that stuff. You know what I'm saying? Because I think at this point I get it now a little bit more, but like, Christoph was bringing up earlier, no one said anything earlier about why we have the I API and the I actors and stuff. It's because we didn't get it, right? We were just like, sure, okay, I guess we need two actors. I don't know, and the ability to see quickly, like, oh, no, we don't need two actors, or, oh, this is how this is going to run. It's going to be valuable for wasmCloud in the future.
I think that is a phenomenal call out, Andrew. And, we do, Steve and I absolutely, I think, are trying to pay attention to the developer experience here and figure out how we can streamline this and make this better. Your example, I think, is a great one to call out, that there's probably even opportunity to like tell the story of how this was created as an example, example capability provider. And, we are, one of the things that actually just happened in the last 2 weeks, I think this was one of the contributing issues, was, we actually wrote up like a developer guide for how to debug this stuff at scale and a few other things. So 100% I agree with you that there is some developer experience stuff we could and should learn here to make this a smoother experience through and through. Steve, I know you've been doing some hands-on on this. What are your thoughts? Do you have any ideas or things you think that we should be doing?
Well, Andrew's 100% right that there are some bumps in the road that people go through when they're learning wasmCloud, and some of them are conceptual, some of them are technical, some of them are like, how do I run this command, and what does this API mean? And all of those are things that can be improved. It's one of the reasons why I'm working closely with Christoph here. It's all the things that we're running into, I'm feeding back into the pipeline and using that to improve documentation and the tooling and stuff. So we definitely love that people are getting the arrows in their back to get through this, and we want to make this really easy over time. We want to make this really easy for developers. That's our prime directive.
Yeah. You know, we actually are getting ready to relaunch our tutorials, Andrew, on Instruct. So those are under development right now. And so the initial, walkthrough is very similar to what's at wasmCloud.dev. Create an actor, is more starting as a user of the tools. But then I imagine we'll launch some content around transitioning in. So I've got a great team working on it. It's Brian Slatton, who has his new WASM book out, is helping to write it. And then Jordan Rash from Capital One is working on the delivery. So I saw a demo this morning. It's a great start. You get a live container on one side with the tools already up, and then instructions on the other, so you can just go through and learn how to do these things. That's the experience we want to give people.
Yeah, it's huge.
To get them in. I agree, 100%. We're making the investment, and expect to see a first draft, I would guess, early March of that, but it'll be up in prime time by KubeCon for sure.
Yeah, that's cool. Yeah, because I mean, just a little bit of background. When I was in IoTG at Intel, that's the Internet of Things group, we had a system similar to this, right? Where we wanted to move compute and data between different nodes and stuff like that. And the complexity, like that's already complex. And then you add in, the specific complexities of whatever system you're building, like, oh, here's how you have to do this and that and whatever. And suddenly it gets just very complex for the users, and it almost, in the worst case, you have to be like the complete expert of the system in order to even build anything that's cool, And so you guys providing documentation and on-ramp tutorials is huge for this type of thing.
On the plus side, there's a lot of complexity here that does go away when you think about the ability to, for the actors and providers, just to work TM. Like nobody.
Yep.
Our idea was, part of the complexity that we swallow is the distributed application part, right? And I think that alone is huge, especially for what we're trying to enable here, which is distributed machine learning. So I agree with you on all accounts that we've got a lot of work to do here to explain it conceptually, give people hand-holding walkthroughs, and I'm trying to do that in a way that is infinitely scalable by investing a ton of time and money up front on like a great training experience. So that's our goal.
Yeah, I think our failure in that project was the routing and the underlying distributed infrastructure was more visible to the user, and that fact, it became unmanageable for the users to understand the mesh. What Christoph is displaying here, right? They had to understand and manage that themselves, and I think wasmCloud does have the advantages that you shouldn't have to worry about that, right? It should just work.
Yeah, I think that's going to be the biggest uplift when we've been meeting with teams, and having conversations about this. One of the things that we kind of ask is, well, what are you trying to do now that you'd want to do distributed, right? Because we just make the distributed piece just easy. So, but great call outs all the way across the board. I really appreciate you thinking holistically and taking a step back on how does this impact the many. Christoph, do we have other content that we'd want to run through with the machine learning agenda, or do we feel like we're at a good stopping place on this one? Good stopping place.
Ready. Yeah.
Super.
Address my points. Thank you.
Bailey, I know you've got a few things in the space going on. Did you have anything you wanted to add, or are you just following along just to stay up to speed with it?
Yeah, right now I'm mostly just learning from Christoph. His comment about streaming in the images did resonate with me. Obviously, my perspective is bringing compute to the data, and not data to the compute. And so my game plan was to use NATs under the covers to stream my images from cats. Actually, mine's dogs, specifically dogs coming into the office. Streaming those images over NATs into my database, and then having both the database and the capability provider that you're creating here, the inference engine, essentially running on the same node. I want to try to eliminate networking as best possible. And I haven't eliminated pushing down a WebAssembly module for inferencing into my database. And since I'll provide a single store capability provider, open source to anybody, that would be a capability, another trick in our toolbox, basically. That might be a slightly different approach from what we're coming up with here.
Yeah, that's really powerful. Now I know underneath the hood, NATS does, when it's set up on a Linux box with the right kernel features, it does all the zero copy stuff, all day long, and is really heavily tuned. But Steve, is there somebody on the Synadia side maybe that we touch base with on what might be the best operational mode to maybe think about how we would turn NATs into a streaming engine in this case?
We could follow. I mean, it is a streaming engine.
We would just bridge it with an actor internally. Is that how we would do it in the wasmCloud world?
Are you talking about trying to avoid having to have an actor in between two capability providers? I'm not.
No, I mean I think
sure what question you're asking.
I think we have to do that. So if we have the NATS capability provider now, so it's going to have to go capability provider to an actor to the machine learning capability provider. But
NATS is already incredibly performant. So I want to know where if there's a performance bottleneck, we could look at that. But I don't know where they are yet because we haven't put this pipeline together.
Okay.
And to be clear, I'm talking about adding NATS support natively to my database. So
right.
We have a create pipeline API for Kafka connections, for example, or S3 data stores that continuously gets updated as they change. I would have a similar ingestion stream, I think, for at least data that's large, like images or video analytics. That type of data tends to cause some different types of bandwidth issues, definitely for IoT devices, at least with the partners I've been talking to about this use case. As far as Synadia people, I've been talking to Steve mostly. Is that your contact as well?
Kevin's been the person on our team who's worked most closely with them. I know he's spent a bunch of time with Derek Collins, who's one of the founders. And so I'm sure we could, if you don't think Steve is the right person, I'm sure we could introduce you to other folks.
Oh yeah, no, right now the bottleneck is 100% me. It's just me getting it done.
Okay. One of the things that's actually it is slightly ML related, but we're looking at some ideas internally to get around the fact that NATS needs a smaller message size, and if you need to send larger payloads, you need to do a little bit of extra work, and we're looking at ways to make that kind of bundling and unbundling of large messages transparent at the API level. So maybe that'd be something you could even use in your ingesting data stream.
Yeah, that's really interesting. Yeah, I intentionally got a 4K little camera. I can give you the specs for that if you want that. It was only $30, so just a tiny little thing. And even that, I did run into some payload issues. I do know that for the most part, I think when people are doing inferencing with images, they usually drop the compress, they do all kinds of things, turn it to grayscale, all that kind of stuff. So there's a lot of other things I can do to drop the payload size.
Yeah, cool. So yeah, we keep finding some great features in NATS. They've put a lot of thought into all of the problems that people have with distributed systems, and they've solved so many of them, from security to reliability and different QoS settings. It's a really nice piece of infrastructure.
Yeah, mainly the parts that I'm putting in is our combining our distributed system with their distributed system, so that we have serendipity. That's the interesting challenge for me.
That is awesome. Okay, well, Bailey, as we pull together what we call Project Chunky Boy, I think it's all going to end up open source anyway, the HTTP chunking stuff. And we do have a customer that's driving that request, so it's got high priority on our side. So expect to see that out public, and if that's useful for you, I hope all the better. And then Christoph, thank you so much for all the hard work on this. And I asked Steve to please just stay engaged with you as you need help. Just be proactive and don't hesitate to reach out and ask, or set up time directly to help you get this over the line. And then just my final call to action would be just the reminder that KubeCon WASM Day EU is May the 16th, and applications are open to submit to speak until February the 28th. So there's still 11 days left. Talks aren't due for a couple months, so you have plenty of time to finish up work. The only thing you need is just your high level description and a few other things. It takes about 10 minutes to fill out an application. It's not that bad as far as getting through. So just keep that in mind. I'd love to get as many great user stories as possible. So I love when users have problems and visions that they care enough about that they solve the problems themselves. That's really powerful. And this is a great case of that, Christoph, where you have a longer term vision for where you think you can go with this, and you're just now you just take the hills, you just continue to knock them all down. So I think it's great. Does anyone else have anything? Andrew, did you have anything you wanted to mention? Or Maxim, thank you for joining us today.
Nope, not for me.
I have a curious question. So in one of the talks you guys earlier on, as I was watching some of this earlier recordings, there was a mention of NATS being a side loader or a side running service. However, I have done some general like search, and stumbled upon NATS RS integration. Am I looking at and thinking of two different things? Would NATS be as a kind of a client that this is piped through be almost a requirement, whereas NATS RS crate wouldn't be even suitable for this case as a replacement to that? Or am I completely confused by this?
It's all NATS. So there's a NATS server, which is a standalone process that runs in Go, and then there are clients for that speak the NATS protocol, and NATS RS is how we connect to NATS from a Rust program. So our actors that are compiled into WebAssembly, actors written in Rust, actors don't directly speak to NATS, but the capability providers that are written in Rust use that NATS RS library, and any other kind of services that use that. And our host uses which is written in Elixir. I saw Andrew had a question about OTP. That's the Erlang OTP implementation of the wasmCloud host that uses a Elixir Nats client. So yeah, we do use the Nats RS. It's the REST client.
Understood. Okay. Thank you so much. That clarifies it. Thank you. Don't have any more questions.
Great questions. Andrew, did you get your OTP question answered, or do you want to dive in that a little further while
Nope.
we're on here? All good?
Yeah, I was thinking it's like one-time password. I'm like, I don't think that's what they mean here. So
Yeah. Yeah, definitely some overloading of terms across the domains here. Okay, well, super. Bailey, thanks for the link on the camera. Christoph, did you get a Coral board, the Google Coral TPU board? You're on mute. You're still on mute. Maybe it's me.
you can hear me. Sounds like we should take this off to the Slack channel.
Yeah, we can pick up on Slack, Christoph, I guess. Real quick, though, I would add that in yesterday's meeting, it'll be on YouTube soon. I'll put a link out in the channel. Brooks did a demo with the Coral TPUs. We're just getting them all ready, wasmCloud packaged up and ready to go and prepped for this. So we're trying to solve in parallel some of the other things we know we got to do for this, but excited for sure. Everybody have a great week. Happy Thursday. Bye.
Bye.